Due to the age and construction elements, the Forbes building is experiencing multiple energy leakages, which increases operational expenditure and has detrimental environmental effects. Buildings of this era were not constructed with energy efficiency in mind, which is particularly evident when compared with modern commercial buildings. Upon investigation, it's evident that lighting is one of the main energy leakages within the Forbes building. There are multiple options that can be implemented to better manage lighting. Lighting is covered within the Building Act in clauses F6, G7, and G8, which relate to visibility and escape routes and both natural and artificial light. Although it's evident that the building is compliant with these lighting areas of the code, the current lighting fixtures and systems are not efficient. And as lighting is the single largest use of electricity in similar facilities, there'll be great benefit in increasing the lighting management. So our first recommendation is increasing natural lighting. Although the ground floor of the building incorporates natural light really well after renovation, the tower has very limited natural light. The tower has very small windows, which is an intentional design consideration, as it was initially used as a library, whereby small windows were installed to limit the natural light to prevent light damage to the books. An increase in natural lighting creates lower operating expenses, and it allows for energy saving and has a positive impact on the well-being of occupants. However, it's unpredictable and harder to control due to the inability to manage and predict the external climate. An increase in natural lighting often leads to an increase in heat, which also must be considered alongside HVAC systems. In order to increase natural light, all existing windows would need to be extended and replaced with larger windows of commercial grade to ensure they withstand the shifting weight of the tower block. Double hung windows with a design pressure of 1920 PA are an installation option. This type of window has an R value of 5.0 and a solar heat gain of 0.22. This option does come with large capital costs, with the cost of renovation, purchase, and installation. Once installed, the management of this option is very low, as it is simple to clean and does not require regular replacement. The installation of blinds may also need to be considered for use on sunny days. So not only is the quality of lighting important when addressing lighting management, but also when it is used. The introduction of control mechanisms through the installation of motion sensors reduces energy use and increases the life expectancy of lighting due to less use, both of which decrease operating expenditure. There are many different types of sensors that can be installed. Our recommendation would be a camera sensor. The camera sensor detection process works by regular images being taken and then compared to see the volume of the pixels that have changed between shots. If there is a large change in pixel volume, then the light is switched on. And conversely, when there are fewer pixels detected, the room is vacant and the light is turned off. The camera sensor requires a constant energy supply to function. However, it's less than the loss that occurred by not having sensors installed. The capital cost of installation is not large, and it is paid off within a short amount of time through savings in energy consumption and fewer bulb replacements. The management of motion sensors is also very low maintenance once installed. They do require regular cleaning to ensure the lenses are at optimal functional performance. And in the instance where the sensor is replaced, they are readily accessible. Finally, the most straightforward option in obtaining light efficiency is through the installation of more efficient light fittings. The current light fittings are aged and non-efficient electricity consumers, thus increasing expenditure costs. We propose the installation of LED lights through all levels of the facility. LED lights use significantly less energy, approximately 5 times lower watt consumption than the regular bulb, and produce a much higher artificial light. The costs associated with LED lights are much higher than standard lighting. However, they do have a significantly longer life expectancy, and obviously, as mentioned, they are more energy efficient. Due to the size of the building, the number of lights and fittings will be high, and distribution installation costs may take some time, thus increasing capital costs. This option is slightly more high maintenance than others. However, the fees associated with the maintenance are not high. The bulbs require replacing and cleaning. However, the low ceiling height makes this accessible. Also, LED lights are a common form of artificial lighting, meaning they are readily available for collection and installation. If this option is used in conjunction with automatic sensors, then maintenance and associated maintenance fees will be even lower.